Okay, hello, and yeah, welcome to another week. Thanks to Matt for organising, as usual. So I'm just going to talk briefly about 1.16, which was released last Friday. Trying to stick to the goal of releasing every 2 months, and I think it was almost spot on. Although, yeah, I wanted to try and get closer to the start of the month, but that's okay. It was still 2 months between. And actually, I think the thing that really held this one up was a bug in async.io erase condition for cancelling a task that was waiting on another task that had an exception. So that took about a week of out of the timeline, but that was really good to find that. And that particular bug, I think, is a really good example of open source software at work, because we were seeing this bug in one project and unable to reproduce it because it only came up very rarely in logs. But it had a very interesting signature of it printed a task, task not handled exception error, but it didn't have a proper traceback when it should have had a proper traceback. And then couldn't reproduce that, but then someone else completely independently on the internet came up with the same bug report of the same symptoms of the same strange no traceback. Although that wasn't really the reason they posted the bug report. It was because it was crashing in a task when it shouldn't have been. And then someone else said, yeah, they saw the same thing with that, and someone posted some code which was reproducible, which could reproduce that bug very easily. Managed to reduce that down to a deterministic reproduction of the bug, because the original code required, you had to run it a bit until it randomly crashed. But then, reproduction of the code deterministically on the Unix report, and then it was only half a day to actually fix it. So that was, I think, a really good demonstration of how open source code, or I guess code that's out there in the open that lots of people are using and that can contribute bug reports for, can become much more robust than some in-house developed code. So it was a nice example of collaboration amongst people using the same code. So I'll just go through some of the things that were in 1.16. The headline here was the MP remote tool, which I did talk about last month. A few bugs were fixed for Windows, like Control-C handling. There's still a few open bugs for Windows that were recently found, not showstoppers, but things to fix. The other headline is the MIMX RT port. So a lot of features were added to this. Pins and ADC UART, file system, and soft SPI and soft I2C. So that's really good. The other fun thing was the REPL auto-completion now auto-completes modules. When you do import, it'll auto-complete module names for you that are built in. So I'll just do a small demonstration. So I have this is a Teensy 4.0, so this is the MIMX RT port. So I can do import. Sorry, that was too big, but import itself is tab completable. It's been like that for a while. But then I can do MA tab, and so I can import machine or math. So it knows what's built in and importable. It doesn't know what's in the file system, but it knows the built-in one. So that makes it really quick to obviously import machine. But if you just do import and then tab again, you can obviously see all of your available modules there. So that's pretty neat. It also no longer tab completes double underscore things unless you put an underscore first. So on previous versions of MicroPython, if you press just tab normally, it would complete double underscore things. But here they're sort of hidden from you unless you explicitly go for a double underscore. Same with machine.tab. It no longer does the double underscore unless you explicitly ask for it.
What are single underscores?
That's the same. Sorry, single and double are treated the same. Yeah. So anything beginning with 1 or more underscores will be hidden unless you explicitly do an underscore. Yeah. So if I do class A and then A dot foo equals 1, A dot, yeah, so there's nothing. A dot bar equals 2. So it template's only bar, but if I put an underscore, it'll tab complete. Well, foo. Yeah. That matches CPython as well. And it wasn't that much of a change. And yeah, so that came from CircuitPython, which is really great. So someone backported that. The other thing, well, while I'm on this MIMX board, you can see the machine module has quite a few things in it now that work. So pins, pin 0, make it an output pin. So the pins on these boards have quite complicated names. I'm still not understanding what they are, but they are what they are in the data sheet. So, but you can do, so pin dot, well, what's the value of this pin? It's low, let's make it high. And it is indeed high, make it low again. So that works. And the other thing you can see, UARTs and works and timers. So machine.timer, let's see if this works, frequency equals 1, callback equals T, print T. So that's periodically, yeah, printing out something. So we do a soft reset. And the other thing, these chips are quite fast. This one runs at 600 megahertz. And I was just trying to make a very quick benchmark. I had this simple test here. It's just running factorial about 200,000 times. And if I time normal MicroPython running that on my computer here, it takes about 200 milliseconds. If I time that running on the board, takes 1.41 seconds. So this board runs about 7 times slower than my laptop, which is actually quite impressive. So 7 or 8 of these boards would be as powerful as my laptop. And these things are, yeah, really tiny. Well, yeah, I mean, that's perhaps a bit unfair, the comparison, but you can see these things are getting pretty fast. It's running at 600 megahertz, so if you get 10 of them, you can think, well, that's 6 gigahertz of power. But my laptop's only, 2 or 3 gigahertz. But PCs are definitely optimized with lots more cache and things. So the comparison is not really fair, but a fun little thing. So I think that's all for that. What other things are on here? So there's a minor breaking change to relative import exception. I don't think anyone's really going to ever notice this. This actually followed CPython's change that if you tried to import beyond the top level of a relative import, it would give a value error. It really should have been an import error, and it's fixed to be an import error. So if your code was expecting it to be value error, it now will break, but I think that's very unlikely. There's a few fixes in UC types, uhashlib. If you try and double hash, if you've got a hash object and you compute the digest, you can't then continue to use it. And now it raises an exception if you try and continue to use it. So that was something that could trip up people before. Yeah, UAsyncO fixed actually 2 race conditions, the one I discussed before, and then another one with starting a TCP server. And it also added a read into method, which was a sort of needed for I2S, which didn't make it into this release, but hopefully the next one. I2S support. ESP32 now has, the ability to specify your own frozen manifest file using CMake. The pixels work on additional 2 pins. Yeah, as Matt mentioned, LAN is added back again. And yes, there's also a new option for Wi-Fi to specify how many automatic reconnect attempts it will make, because, well, by default, it will just always try and continue to connect to the Wi-Fi, even if the Wi-Fi disappears or if you have the wrong password. But this option allows you to control that to say, don't continue to reconnect, and warn, tell me that something's gone wrong, and the app can try and fix it. Yeah, MAX port we already discussed. The RP2 port has machine RTC to configure the RTC, and a few more board definitions. And the STM32 port has a few changes, some low-level stuff. mboot had a lot of changes to make it more configurable, the bootloader. That's really if you just want to fully customize mboot, which is not something that the average user of MicroPython would do. But yeah, it's there if you need it. Yeah, there was a bug fix also for the wireless LAN on PyBoard-D when you're using SPI as well as Wi-Fi. The SPI DMA usage could interfere with the wireless LAN, but that was fixed. And yeah, pins. The UART does no longer pull up TX and RTS. Hopefully that doesn't break anything. It shouldn't. And there's a new IRQ method on USB VCP so that you can get an event whenever there's incoming data on the USB serial. The Zephyr port also has now initial Bluetooth support, but it can do scanning and advertising, but nothing else yet. But it's the same Bluetooth API that we have for ESP32 and STM32. So hopefully that will get fleshed out eventually. And the idea, of course, is to make it so that any Bluetooth code you write can run on any board in the same way. And that's all in this summary. So yeah, thanks to everyone who contributed. There were lots of people. All these things, I can't do all that myself, but I can merge them and review them. But other people write a lot of this code. So thanks to everyone who contributed. And thanks again to Espressive for their really big sponsorship on GitHub, which has led to trying to keep the ESP32 port up to date, which has just nearly got C3 support, ESP32 C3 support. Anyway, you can read the rest of these details here if you're interested. That's all I have to say. Thank you.
Support.
Oh yeah.
Agreed with some.
Yeah. That got missed out of 1.16 as well. It is on my list, and it is They can't hear me. Oh. PWM support is a question about PWM support on ESP32, and yes, I'm aware of this, and we want to get to it as soon as I can. Also on STM32, I want to make machine.pwm work simply there, just like the other ports. That has been on my list for a long time, and too many things get in the way. Maybe next release. I think there's enough. Yeah, for the next upcoming release, I really do want to get onto that, and don't have any apart from just trying to continue to tidy up all the open pull requests, which Jim and I have made progress on. There isn't anything really big planned. So PWM would be a good thing. Yeah, I mean there's just a whole lot of open stuff like Peter's SAMD things. I want to get those in as well, and just
lots of stuff.
it just keeps coming every day. It's like,
who's been working on the C3?
Oh, I did a little bit of that, but I don't have a C3. So someone online was just testing it, and we were doing a really good job of testing it. Yeah, so that's almost up to par with standard ESP32. And actually, it's testament to the IDF. There wasn't much to change, and it just worked, even though it's an entirely new architecture, RISC-V. they've kept the peripherals the same, it seems. So
I think so. Just replace the core.
yeah, it's good, and I guess it's a good move because it's cheaper than and it's, for long term, I think it's a good option. We'll see how it goes. Yeah. Any other questions? Sorry, Sian. PWM will get there. Just ping me every day and we'll get done. Actually, yeah. You will. All right. Thanks, guys.
Thanks,